In this video, we're going to learn about function notation. In more advanced math classes, function notation makes complex algebraic expressions and equations much more manageable and understandable. So let's dive in and learn all about function notation. With an equation like y equals 2x plus 6, we can rewrite that in function notation as follows. We just say f of x equals 2x plus 6. Now, we see here the only thing that's different is instead of writing y, we have this f and the x. Now, this does not mean f times x. With function notation, the f is actually just the name of the function. So this function over here is the f function. And whatever goes inside parentheses after the name of the function, that's the input. So a lot of times it'll be a number there, and that's just telling you what number you need to plug in for x. So let's compare once again. Over here we have an equation in slope-intercept form. Over here we have that same equation or same expression, except now it's in function notation. We say f of x equals 2x plus 6. Now we don't need to use the letter f for all functions. Sometimes we'll see other letters. A lot of times, in fact, we see the letter g used. So we could say g of x equals 4x squared, just to make up some other function. Okay, let's practice writing expressions in function notation. So here we want to write f of x is equal to x minus 5, all divided by 4. So f of x, that is just written as f parentheses x, where f is the name of the function, and x represents the input, is equal to, so that's an equal sign, x minus 5, all divided by 4. I think the easiest way to write that would be as a fraction. So x minus 5, all divided by 4. Y is x plus 2, all multiplied by 4. So this is going to be an equation. So y is, that'll be y equals x plus 2, all multiplied by 4. So I think the nicest looking way to write that would be 4 times the quantity x plus 2. You could put 4 afterwards also, but it looks nicer up front here. F of x is equivalent to x multiplied by 5, all squared. So once again, we have our function notation. F of x is equivalent to, that's just an equal sign, x multiplied by 5, all squared. So x multiplied by 5, the nicest way to write that would be 5x and squared. Okay, let's move on to evaluating with functions. Now here, they're asking us to find g of negative 3 if g of x equals negative 6x plus 3. Now this negative 3, that's the input. So we're going to take that negative 3 and substitute it in for x on the right side of the function. So this doesn't mean g multiplied by negative 3. It's just telling us to plug in negative 3. Okay, so we've got g of negative 3 equals negative 6 times the input plus 3. Now we're not going to do anything on the left here. There's nothing to do there. It's just the name of the function, and it's telling us what the input is. So g of negative 3 equals, using our order of operations, we'd multiply first. So that'd be 18 plus 3. So we see that g of negative 3 equals 21. Here's another function to evaluate. We want to find f of negative 36 if f of x equals 16 plus x over 4. So we're going to substitute negative 36 for x on the right side of the function here. So we have f of negative 36 equals 16 plus the input, divided by 4. So we'll treat this fraction as a division problem. And negative 36 divided by 4 equals negative 9. And 16 minus 9 equals 7. So f of negative 36 equals 7. Here we're trying to find h of 3. If h of x equals negative, or we could say the opposite, of negative 22 plus x over 6. Right, so the function is named h. It's the h function. And they're telling us to plug in 3. So we're looking for h of 3. So we just need to substitute 3 for x. Let's not forget about all these negative signs. So the opposite of negative 22 plus the input all over 6. All right, we understand there's parentheses around this numerator, so we do that first. H of 3 equals the opposite of, let's see, negative 22 plus 3, that's negative 19 over 6. We look at the numerator and denominator, we can't simplify those, so we're all done there, but we do have these double negative signs, and those cancel each other out. So the opposite of negative 19 over 6 equals positive 19 over 6. And here we have some absolute value functions to evaluate. We're wondering what h of 7 equals. So notice here they're telling us that a equals 7, and a is the input. So we're looking for h of 7. Remember, there's no math to do on the left side here. It just says plug 7 into the function named h. And here's our function named h. We take the absolute value of the input plus 4. So h of 7 equals the absolute value of 11. And the absolute value of 11 is equal to 11. One more function involving absolute value. Notice there's an absolute value sign inside another absolute value sign. Okay, so here they're telling us to evaluate g of k when k equals 9. So they're telling us the input is 9. So we want g of 9. So we want the absolute value of the input plus the absolute value of negative 7. And the absolute value of negative 7 is positive 7, so we want the absolute value of 9 plus 7. And 9 plus 7 is 16, and the absolute value of 16 equals 16. So g of 9 equals 16. Now we can also evaluate a function from a graph instead of an expression. Okay, so let's think about this. We're trying to figure out f of 8. So they're telling us the input is 8, and that is our x value. So our input is the x value. So they're telling us, they're asking us, what does y equal when x equals 8? Or in other words, what is the y coordinate when x is 8? Well, let's look down here on the graph. So when x is 8, we're out here. And let's go straight up from 8 on the x-axis up to the line. And that point is the point 8, 11. So f of 8 equals 11. Because when the x value is 8, the y value is 11. Or when the input is 8, the output is 11. Special situation here with a horizontal line. We're trying to find the value of f of negative 6. Or in other words, when x is negative 6, we're wondering what the y value equals. When the input is negative 6, what's the output? Okay, so when x is negative 6, the graph here is at the point negative 6, negative 2. So in other words, f of negative 6 equals -2. When x equals -6, y equals -2 for this blue line here. Or in terms of the function, when the input is -6, the output is -2. I hope this introduction to function notation has been helpful. This is Mr. Ela, signing off.